Hey, scholars, it's been a long while. Happy New Year! In today's class, I'm going to be showing you a typical example of a section through a floor plan while showing you the roof detailings. Thereafter, we proceed to other aspects of the sectioning in the course of our classes. Stay tuned. First, we'll be working with a facial concrete of 600 eaves projection and about 150 millimeter thick. So, and for us to achieve that, which will be here and also here at this end, for us to achieve that, take our measurement. Since we are making use of 1:100, which is quite very small, we take a measurement of 50 from the outside of our wall. Then let's take another 50, and I think yes, then at the far edge of our facial board, the other time I said our facial board is 600 each projection. Its each projection is 600, so we take another 50 inward at the 550 mark, then the 500 mark. Yeah, the 500 mark. Alright, so with that being done, I then have the design I want for my facial concrete. Okay. Do note you are meant to use a construction outline because you are not sure how it's going to turn out. So in order for you to erase easily, I would advise you make use of your construction outline, a thin continuous line to be precise. But for clearance, I've decided to take it out. Alright, so same thing being done. So same thing being done at the other side. Your 50 millimeter. So in this video, we are going to be doing mainly the roof members detailings. Then thereafter, in our next video, we then have that of the arrangement of furnitures inside the building, and then our foundation lastly. Then we have a circle template to show the curve of our concrete fascia board. Okay, and here we have it. The other side. Alright. The next thing to do is to connect this point to somewhere around there in order to show that the concrete fascia flushes into our wall. Yes, and for us to do that, take a measurement of 450 up here. Yes, 450 millimeter. Same thing here, 450 millimeter. Then we then join the 2 points. The other time we measured 150 inward from our wall. Same thing here. We measured 150 millimeter inward from our wall, the end of our wall. So then join both points together, showing us the thickness our concrete fascia of which is equivalent to 150, right? Then you take in. Alright, the distance from this point to this other point is equivalent to 450 millimeter, whereas the distance from this warhead to this very point is 150. Why from from where we have the facial concrete stopping to the end of this wall here is equivalent to 75, since 150 plus 75 is equivalent to 225. So same thing at this edge here. So we now have a concrete fascia of 150 millimeter thick flushing into our wall. In order for you to know that yes, it's flushing in, is that is due to the fact that these points and these lines are not joining. There's a space in between them. Same thing with this. So this is to show that yes, the fascia and our concrete fascia is flushing into our wall. Alright, as time goes on, I'm going to show you in our next class. So right now, we want to show our roof members, and for us to do that, project our pitch angle, make use of um, whatever angle you want to work with. You can make use of your angle 30, angle 25 degrees, angle 15 degrees. It depends on whatsoever angle you are working with. It's not a compulsion to use um, just an angle. You can decide to use any angle you want to work with. So yeah, so I'm working with 45. Alright, so after taking our concrete fascia board, what next is to have our wall plate just on our wall, and we all know that wall plate is at times in the dimension 50 by 75. The 50 represents its thickness while 75 is its height. So we then measure our 75, then 50, and we all know that all plates rest on each of the walls. So take out your measurement of 50 for each of the walls. Alright, so we have our 75. We should note that some wall plates run longitudinally and some runs cross-sectional. We cut through the part of the cross-sectional, which is 50 by 75. Okay, right here, 50. It's quite minute. I don't know if you can see that. Lastly, okay, I'm taking it out. Then just right on our wall plate, we have our tie beam. Tie beam a is of diameter 50, 50 by 150. At this part of the roof section, we are seeing the 150 millimeters. So, and for us to have that, take our measurement of 150. Do ensure that you work with scale 1 to 100. Alright. And do ensure you use a thin continuous line because we are going to be showing some detailings. Detailings are not meant to be hidden, they are meant to be seen. So thereafter, we start from the center. Yes, since and we all know that the highest point of a roof member is being held by the king post. Yes, and we have the king post, we have the struts, we have the tie beam, the purlins, the rafter of the roof member. So, and the king posts and the struts are always at 1,200 center to center. So in this case, the roof is showing a cross sectional, a longitudinal at the center, and a cross sectional at the other side. So, and for us to represent the cross sectional aspect, we have our king post and our strut being shown. Whereas in the case of the longitudinal, we have both the king post and the purlin being shown longitudinally. Alright, let's continue. So before that, we have to add our rafter because the king post is being nailed to the rafter. So for us to add our rafter, you know that this line right here will represent our roofing sheet, but let's leave it that way. Don't let us stick in it yet. And just before we have our roofing sheet, we have our purlin. Purlin is always 50 by 50 millimeter, and for us to measure that out, we draw a line perpendicular to this other line in order to measure a precise 50 millimeter. Yes. Thereafter, we take our measurements of 50 millimeter and then our measurements of 150 millimeter for our rafter. Do ensure you are working with scale 1 to 100. Alright, 50 millimeter, and right here we have 150 millimeter. Okay, with that being done, then draw a line parallel to this outer line at 50 millimeter to it, and at the same time 150, no, that will be 200 to it, giving us our rafter of 150 millimeter. Okay, then taking it because the construction outline. Okay, up next is to have our 50 millimeter running longitudinally, and for us to achieve that, we have a straight line at the intersecting point of the outer line. Do remember that the outer line is a roofing sheet, though it's yet to be taken. Alright, up next is to draw our longitudinal aspect of the purlin, which is at 50 millimeter to the roofing sheet, while ensuring it intersecting the straight line. Then we then transfer our rafter. Do note that we are not showing the rafter at the longitudinal aspect, but we need the dimension in order to get for this other side. So we then transfer this dimension to this other point here, Thereafter, we draw a line parallel to the outer line at 50 millimeter, giving us the space for our purlin. Then another one at 200 millimeter, giving us a rafter for this other side. Okay. Up next is to draw a king post. King post is always 50 millimeter by 150, and in this part of our roof section, roof member, we are going to be seeing that of 150 millimeter. So, and we have our king post right here. So we then measure 75 millimeter to this side, then 75 millimeter to the other side in order to make up a 150 millimeter. And for us to achieve that, since we all know that the king post is always nailed to the tie beam and also to the rafter. Alright, so then at this side to our left, we are going to have our strut, the vertical strut placed at 1200 center to center. So from our king post, we take our measurement of 1200 at its center to the center. So repeat same for other struts member which are at 1200 center to center. Alright, so strut, unlike king post, is 50 by 100 millimeter, and in this case we are seeing that of the 100 millimeter, unlike our king post which is 150 millimeter. The king post, the struts are also nailed on our rafter and our tie beam, so you can do it lightly at first. Then once you are done, we are going to thicken it out. Then we may decide to have one very close to this edge in order to hold the tie beam and the rafter, since they are not connecting as a result of our fascia concrete fascia board. So we then connect them with a vertical strut. This is done in such a way just to hold the tie beam to the rafter firmly. So we then repeat the same procedure to this other side. Do note that the longitudinal aspect of our roof member will be treated differently. More reason why I'm yet to touch the part. Okay, 1 2 center to center, 4 1 2 center to center, then let's have one more here. All right, don't forget that your strut is 50 by 100, in which we are showing that of 100 millimeter at this side, and it is nailed to our rafter and the tie beam. You must show it that it's nailed to them. That's why it's called detailing. It's not meant to be hidden. It should be visible. And lastly, let's add one more at this edge in order to connect the tie beam to our rafter. Alright, so up next is to join the diagonal strut. Do ensure that the diagonal struts are nailed to the front of our rafter and our tie beam, and they are nailed in such a way that they are laid side by side to the to both the vertical king post and also the vertical strut. Why? Because we can't have three of them being joined together. We having three of them being joined together will make an addition of 50 millimeter by 50 millimeter plus 50 millimeter plus another 50 millimeter, making it 150 in total. Then in that sense, it's going to the wood is bound to tear while nailing them together, and at the same time, we won't achieve a structural balanced roof. So they are laid side by side in such a way that 50 is nailed to the rafter, 50 is nailed, 50 plus of the 50 of the struts, 50 thickness of the strut, and 50 millimeter thickness of the rafter are nailed together, whereas the vertical strut also of 50 millimeter thickness are also nailed to 15 meters rafter and tie beam. Alright, so for us to achieve this, we make use of our adjustable set square. Yes, they are not at fixed angle to each other, so you have to adjust them in order to fit in. Do ensure that your vertical struts run to the end of your rafter and tie beam. This is to ensure that yes, or this is to show that yes, they are nailed on your tie beam and rafter. Okay, what next is to show the connection. Since they are laid side by side, so you measure 100, 100 from your king post. Measure out 100 at the head, at the end of your king post here. Measure out 100. Then just after your strut here, measure out 100 to this other side. Okay. Then we join it to the first edge. And lastly, to the last edge. Then repeat same procedure for all other members. You may decide to thicken it so as to avoid repetition and to save time, since this is meant to be shown that it is nailed to your rafter and your tie beam. So to avoid repetition and you are very sure of which point they are on, you decide to thicken it out. Alright. Same thing to others. One thing you would note is that once you set your adjustable set square, you notice they are parallel to each other. which tells you or which depicts that your work is accurate. Yes. Okay. Repeat same procedure for this other side. Do ensure that do note that it's we've just been working on the cross-sectional aspect. The longitudinal aspect is to be treated specially. Alright. So at this edge, we have our king post. So we take a measurement of 100 to this side, then 100 from this tip where our struts, vertical struts stop, 100 to this other side. Alright, just as we've done here. Okay, so it's time to join it together. Then for you to maintain cleanliness, you have to avoid direct contact with your paper. Your instrument should be well cleaned, and as a result of that, you can try and make use of your instrument instead of your hand touching your paper, thereby leaving stain that can't be erased. Alright, we then take in our vertical strut and king post. You notice this side of our of our strut and king post are slant, and there's a way they chamfer it off while on site. So, alright, we then taking our rafter. Should pay attention to your graphics. Yes, the king post, the struts, they are nailed to the rafter. So you ensure they are more thicker than a rafter, since rafter will be behind it. The rafter will be just behind it, and you have to show that. You ensure you show that. This will go a long way to earn more mark. Just behind it, nailed just behind it. Right. Okay, you can then close it up here. Yeah. Our rafter will stop somewhere here, because we can't have our rafter pushing our facial concrete. So it must not push it. It's wrong. Just so long. Okay. All right. So we are good to go. Close it up somewhere here. Our roofing sheet is just about zero point 0.2. It's just about 0.2 millimeter thick. So it's not supposed to be represented with two lines. You can just represent it with a thick line just to show that yes, you've cut through it. Just a single thick line. Yes. Then thereafter we add our pollen to this other side, to this side and this other side, just to show that yes, the pollen is nailed to the rafter on the rafter. Then we have our roofing sheet being nailed to the pollen. Right, and for us to ensure that we all know that pollen are in most cases and generally at 900 center to center. So, and our pollen is in most cases 50 by 50, 50 by 50 millimeter thick, being placed just right on a rafter, nailed to it at the top. Alright, so we decide to have our pollen starting somewhere here, just very close up here. Okay, then you then take it 900 center to center. 900 center to center. Okay, and we all know that it will be perpendicular to our roofing sheet, perpendicular to our rafter. Yes, being placed since we cut through it cross, we cut through it cross sectional plane. So it was cut through its cross sectional plane. I don't know if it's visible. Is it visible and clear? Please do ensure to comment so as to know what to improve on our next class. Is it its visibility or my explanation? Well, to like if you've liked if the video is helpful too. Thanks. Then we can just have one very close to the rafter here. Yes. All right. Then okay. Then repeat same procedure here. So instead of us measuring 900 again, can just transfer it with the aid of our c square to the other side. Right. We are good to go. Up next is to show our roof members through the longitudinal aspect. So just note that in the next longitudinal aspect of our roof member, we are going to be seeing our um, king post of the 50 millimeter side of our king post or two. And king posts are placed 1200 center to center also. So we take our measurements of 1200 center to center. And right here is actually same as 1200. So we have just one at the center, but in this instance, it's at 50. We are showing it at the 50 millimeter and the side of the we are showing that part of 50 millimeter since king post have two members, two sides. We have that the part of 150 and the side of and that part of 150 50 and 150. So in this instance we are showing that of 50. Same thing goes with Apollin. Apollin is shown just behind the king post. Why? And it is shown faintly in the sense that it's afar off, being nailed to a rafter. But we are not going to show that of rafter because the king post right here is blocking our rafter. Yes. So the Pauline right here is also 50, but this time around the longitudinal aspect, longitudinal section. sectional, longitudinal sectional, and it's drawn faintly. So you can just project your poly from the other one we've measured, the 930 center we've measured longitude, make it, this time around we are making it longitudinal, just behind. So it will be behind our king post. For you to achieve small detailings being shown, I recommend 5H pencil. 5H pencil is good when you want to work with and and a thin details, and it will even bring out your work well. 5H pencil is good, very thin detailings. And you can also make use of your clutch pencil depending on which one you are good at. Alright, clutch pencil is also a good one. Alright, then before you thicken, ensure you've gotten the precise point, because once you thicken with your 5H pencil, it's very difficult for you to erase. It's hard pencil. Hard pencils leave marks, they leave traces of your mistakes. So do ensure you've gotten the precise location of your, or the precise point where your lines are meant to be. Alright. So next thing is to show tie beam. We all know that the tie beam and the king posts, the struts, they are also nailed to our tie beam. So we must show the detailings that yes, the king post and struts are nailed. And lastly, we show our tie beam. Yes. Yeah. And here we have it. So in our next class, I'm going to show the furniture arrangement, our windows, our walls, and probably in our next class, we are going to go about the foundation detailings. Thanks. So you may decide to thicken out your vein sheet also. Right. Here we have it. Yeah. And to make it more neat, you decide to use your 6B, make it more realistic and neat. Make use of your 6B. Yeah. Yes. Then we are good to go.
Alright, do
Thanks
well
for
to
watching.
like, subscribe, and share the video. And also, stay tuned for more content by clicking on the notification bell, as more content will be dropped relating to architecture and engineering drawing. Remember, the only way to overcome your fears is by facing them head on. I remain Hemmy, your tutor here at Hemmy Consult. Thanks.